Hello everyone, my name is Dr. Vile and welcome to my A-Level Chemistry YouTube channel. The purpose of this channel is all about getting you ready for your A-Level Chemistry exams, and this video is going to focus on equilibrium chemistry and how we use something called ICE tables to solve problems. So ICE tables are where you have the initial number of moles and you have the equilibrium number of moles, hence I and E. I for initial, E for equilibrium, and then C is the change between the two values. And we can use this to solve a variety of problems. So on the screen at the moment is an example question with the equilibrium sulfur dioxide and sulfur trioxide, and you're given a lot of information there. So what I would suggest you do, if you've covered this topic before and you just want to practice, I would suggest pausing the video, have a go at the question, and then watch me go through the answer. If you've never seen this before, then maybe you just want to keep on watching, and I'm going to go through how to tackle this problem. Okay, so with this question, the first thing I would do is make an ICE table. So you've got I, which is the initial, you've got C, which is the change, and then you've got E, which is the equilibrium. And then you put everything else into the table. So you're going to have two lots of SO2 in the first column, one lot of O2, and then two lots of SO3. And it says initially they mix together 1 mole of SO2, so we put the number 1 there, half a mole of the oxygen, and because SO3 is a product, the initial number of moles must be 0. So that's the first row. At the moment, remember this is all in your 250 centimeters cubed, so we'll allow for that in the last step. It then says the mixture reached equilibrium at constant temperature and 82% of the SO2 had been converted into SO3. That's the key phrase. So that means that the SO2 must, if it was 1 to start with, it must have gone down by 0.82, which is 82% of the 1 that it was initially. So if it started at 1 and it went down by 0.82, then you would be left with 0.18. Now the O2 must also have gone down, but it must have gone down by half the amount, because it's a 2-to-1 ratio, so it must have gone down by 0.41. Whereas the SO3, because it's a product, must have gone up, and it must have gone up by the same amount that the SO2 went down, so that's plus 0.82. So that leaves you with 0.09 for this one, and 0.82 for this one here. Now these are the equilibrium moles in 250. So we need to work out the equilibrium concentration. Now remember that's moles per decimeter cubed, whereas there's 1,000 centimeters cubed in a decimeter cube, so we simply times these by 4. So that gives you 0.72, 0.36, and what would that be, 3.28. And now we're in a position where we can write out our Kc expression. Kc is equal to the concentration of the SO3 squared divided by the concentration of the SO2 squared times the concentration of the oxygen. So we then plug the units in. That's going to be 3.28 squared divided by 0.72 squared times 0.36. And that comes out as 57.6. In terms of units, you've got 2 lots of concentration on the top and 3 lots of concentration on the bottom. So when you cancel down the units, kind of these ones cancel down with those ones, which leaves you with one lot of concentration on the bottom, which is therefore moles to the -1 dm to the +3. Thank you for taking the time to watch this video. I hope you found it helpful and informative. If you find these videos helpful, please make sure you like them, subscribe, and keep checking back for more content. Thanks everyone, see you next time.